Next problem. Find the inverse transformation of 4z square minus 2z by z cube minus 5z square plus 8z minus 4. Let f of z, which is equal to 4z square minus 2z by z cube minus 5z square plus 8z minus 4. So that is equal to taking 2z outside, right, because it is common in the numerator. So 2z into 2z minus 1, z cube minus 5z square plus 8z minus 4. So taking that z, the left hand side numerator, to the right hand side denominator. So f of z by z, which is equal to 2 into 2z minus 1 by z cube minus 5z square plus 8z minus 4, right? Otherwise you can multiply z on both sides, so you will get divided by z on both sides, so you will get the same results, right? Don't get confused, right? So equation number 1. So consider 2 into 2z minus 1 by z cube minus 5z square plus 8z minus 4 is equal to 2 into 2 minus 1 divided by, so factorizing the denominator, so you will get z minus 1 into z minus 2 into z minus 2. So you know how to factorize the cubic polynomial, right? Synthetic division you can use, that is easy one. Easiest one is synthetic division, right? So by synthetic division you can easily find the factors of the cubic equations, whatever the degree, right? Now 2 into 2z minus 1 by z cube minus 5z square plus 8z minus 4, which is equal to 2 into 2z minus 1 z minus 1 into z minus 2 into z minus 2 z minus 2 the whole square. That is equation number 2, right? I think you know synthetic division, right? So take the coefficients of the polynomial 1 minus 5 8 minus 4, right? So adding alternate terms, so 1 and 8, right? Z cube coefficient 1, z coefficient 8, so 1 plus 8 9. Then another alternate coefficients, right? So z square coefficient minus 5, then constant term minus 4, minus 5 minus 4 minus 9, 9 minus 9, adding these two, right? 9 minus 9 you will get 0, then minus 1 is the factor, right? First term. Then you can do the synthetic division. So write the coefficients, then put minus 1, right? Then you can put 0, then you can do the synthetic division. I think you know, it is familiar one, right? So let 2 into 2z minus 1 by z minus 1 into z minus 2 the whole square equal to, take it, a by z minus 1 plus b by z minus 2, because you are having z minus 2 the whole square, so you have to take separately, right? That is the partial fraction method. So c by z minus 2 the whole square, that is equation number 3. Now we need to find the value of a, b, c. Multiply both sides by z minus 1 into z minus 2 the whole square. So 2 into 2z minus 1 into 2z minus 1 into z minus 2 whole square by z minus 1 into z minus 2 the whole square, which is equal to, multiply separately to each terms, a into z minus 1 z minus 2 whole square by z minus 1, b into z minus 1 z minus 2 whole square by z minus 2, plus c into z minus 1 z minus 2 whole square by z minus 2 whole square. Now in the left hand side, z minus 1 into z minus 2 whole square cancel the numerator and denominator, remaining term 2 into, right, 2z minus 1. Now come to the right hand side. So first term z minus 1 and z minus 1, numerator and denominator get cancelled. So first term a into z minus 2 the whole square, plus second term z minus 2 and z minus 2 get cancelled, remaining you will get z minus 2, right? Because z minus 2 the whole square, the numerator. So second term b into z minus 1 into z minus 2. Then last term So z minus 2 whole square, z minus 2 whole square, numerator and denominator cancel. So you will get last term c into z minus 1, right? Correct? That is equation number 4. Now to find a, right? A. So first we need to find c. So put z is equal to 2, right, in fourth equation. So you will get 2 into, instead of z you replace by 2, right? 2 into 2 minus 1 plus, instead of z you are putting 2, the first term a into 2 minus 2 whole square 0 plus b into 2 minus 1, then second term 2 minus 2 0, 0 into something 0. So first term and second term get cancelled. So last term when you are putting 2 instead of z, you will get c into 2 minus 1, right? Therefore c. So c, this implies c equal to 2 into 2, right? 4 minus 1, 3 into 2, 6. C equal to 6, right? Now to find a, next. So to find a, just to put z is equal to 1, right? Then b and c get cancelled, right? Put z is equal to 1 in 4. So 2 into 1 minus 1 is equal to a into 1 minus 2 whole square. Plus 1 minus 1, b into 1 minus 1, 0. 0 into something 0. And c into 1 minus 1, 0, right? So a into 1 minus 1 square, 1 square a. Therefore a equal to, so 2 minus 1 into 2, that is a equal to 2. Next to find b, put z is equal to 0, because no way, right? So just I am taking z is equal to 0. It is easiest way, that is why, right? For any problem you can take like this, right? So 2 into 0 minus 1, which is equal to a into 0 minus 2 whole square, plus b into 0 minus 1 into 0 minus 2 plus 0 minus 1, c into 0 minus 1. So left hand side you will get minus 2, right? In the right hand side you will get an equation in ABC, 4a plus 2b minus c. That is equation number 5. But we know the value of c and a. C is equal to 6, a is equal to 2. Substitute the values, you will get minus 6 plus 2b plus 4 into 2 is equal to minus 2. Therefore b is equal to minus 4 by 2, that is equal to minus 2. So again, so we are going to our main problem. From 1 to 3, you will get f of z by z, which is equal to a by z minus 1 plus b by z minus 2 plus c by z minus 2 the whole square. Substituting the values of a, b, c, 2 by z minus 1 plus minus 2 by z minus 2 plus 6 by z minus 2 the whole square. Multiplying z on both sides. So f of z, which is equal to 2z by z minus 1 minus 2z by z minus 2 plus 6z by z minus 2 the whole square. We know f of z is equal to z of f of n. Therefore z inverse of f of z, which is equal to f of n, is nothing but z inverse of each terms, right? Taking z inverse, right, on both sides. And f of z, which is equal to 2z by z minus 1 minus 2z by z minus 2 plus 6z by z minus 2 the whole square. So z inverse means you will get f of n, which is equal to, so z inverse of the right hand side. So taking separately z inverse of 2z by z minus 1, taking 2 outside, 2 into z inverse of z minus 1. So similarly the second term, minus 2 into z inverse of z by z minus 2 plus the last term. The last term I am keeping 2 inside and taking 3 outside, because 6 can be written as 2 into 3. So I am keeping 2z inside and taking 3 outside, 3 into z minus z inverse of 2z by z minus 2 the whole square. Because it is easy to apply the formula directly, that is why, right? Small adjustment. First one, we know z inverse of z by z minus a is equal to a power n. So in the first term, the place of a you are having 1, so 2 into 1 power n. The second term, the place of a you are having 2, so 2 power n minus 2 into 2 power n. the third one, we know the formula Z inverse of AZ by Z minus A the whole square, right? That is why we are keeping that 2 inside, right? We know Z inverse of AZ by Z minus A the whole square, that is equal to n into A power n. So instead of A you are having 2, that 4, that is equal to 3 into n into 2 power n, right? These are all the formulas. Therefore, first term 2, right? 1 power n 1. Second term 2 power n, grouping the powers 2 power n plus 1. Third term plus 3n 2 power n. Therefore, inverse is a transformation is 2 minus 2 power minus 2 power n plus 1 plus 3n 2 power n. That's all.